Welcome back to the channel. I'm Xavier Smith, and today I'm going to talk about rational expressions, multiplying, dividing, subtracting, adding, simplifying, and finding a common denominator. So let's go. Rational expressions. What do they look like? X over 2x plus 6. These are just examples. 5x over x plus 7. X over x minus 1. X squared plus 5x plus 6 over x squared minus 4x. And they are a fraction where both the numerator and denominator are polynomials. So they have variables in them. So simplifying, x squared plus 5x plus 6 over x squared minus 4. First, we're going to factor that. So x plus 3 times x plus 2, because x squared plus 2x plus 3x plus 6 is x squared plus 5x plus 6. And x squared minus 4 is x plus 2 times x minus 2. And then here, we have an x plus 2 in the numerator and denominator. So we can just cross that off. And then move these on down. So it'll be x plus 3 over x minus 2. Next, now that we know how to simplify, we can already multiply and divide these. It's crazy how fast it goes. Multiplying and dividing. So we're going to do x squared plus 5x plus 6 over x squared minus 4x times 4x over x plus 2. So first we do x plus 3 times x plus 2 over, we can take an x out of x squared minus 4x, x times x minus 4. Then times 4x and x plus 2. So first, to simplify, we have to look for what we can see in this. The denominator of the first one can cancel with the numerator of the second. The numerator of the first one can cancel with the denominator of the second. The numerator of the first one can cancel with the denominator of the first one. And the numerator of the second one can cancel with the denominator of the second one. The only ones that can't cancel are the numerators of the two expressions and the denominators of the two expressions. So I see an x in both of these. I see 4x, so I'm going to cross that off, and x. And I don't see anything else. Oh, I do. Oh, x plus 2. We can cross that off as well. So you always got to make sure you're simplifying correctly, because you could have missed something like me. So, excuse me. We bring down the 4 and the x plus 3, and we multiply them together. I'm just going to leave it as 4 times x plus 3 over x minus 4. So we just simplify numerator and denominators, then bring it down. Excuse me. For our division problem, we're going to do x squared minus 2x over x squared minus 4x plus 4 divided by 4x squared over x minus 2. This may seem complicated because you don't want to divide polynomials, but division of a radical is the same thing as multiplication by 1 over that number. So this 4x squared over x minus 2 goes to x minus 2 over 4x squared, and then it just turns to multiplication. So we do the same thing. We factor an x out of the x squared minus 2x. We factor the x squared minus 4x plus 4 to x minus 2 times x minus 2. This x minus 2 moves up because the 4x squared over x minus 2 flips. And now it is x minus 2 over 4x squared. And then we see what we can cancel. All right, so I see an x minus 2 in this numerator, and I see one in the denominator as well. I see another x minus 2 in the denominator, and I see one in this opposite numerator, so I can cancel those. I see an x here, so I'm going to cancel that with this x squared here, and then that x squared turns into an x. So this will be 1 over 4x. Just make sure if you're solving that now x equals 2 cannot be in this equation. So whatever x has been in the bottom before, that can make the denominator 0 at one point, that is not an allowed value. So here we're going to see an x minus 2 and a 4x squared in the denominator. So that means x cannot equal 2 or 0, because that would make the equation undefined, and we can't have an undefined equation. Here, we have had an x plus 2 and an x minus 4 in here. So using the zero product property, x cannot equal, what are we going to say, negative 2, because here it would be 0. It cannot equal 4, because here would make it 0. And we cannot have x, because here would be 0. So just make sure you have those values if you're solving or you are asked for them. Moving on. So getting a common denominator. This is essential for addition and subtraction of these. X plus 2 over x minus 3 and 2x plus 4 and x plus 4. I'm just going to try to get a common denominator here. And then after, if we wanted to, we could just add these or we could subtract these. Doesn't matter. They have a common denominator. So here, x plus 2 and x minus 3. We see this x minus 3 here, and we see this x plus 4 here. So you got to think, what is the least common denominator I can get, least common multiple? I see these x minus 3 and x plus 4, and I just say, okay, it's x minus 3 plus x. No, x minus 3 times x minus 4. Sorry. So I'm going to put this up at the top here. The least common denominator is x minus 3 times x plus 4. And then we do just that. So this denominator is missing an x plus 4. So I'm going to multiply x plus 2 over x minus 3 times x plus 4 over x plus 4, which x plus 4 over x plus 4 is the same thing as multiplying by 1, and multiplying by 1 keeps the number the same. So I'm basically multiplying by 1 here, but I'm getting a common denominator in the process. And then here, 2x plus 4 over x plus 4 is missing an x minus 3. So I'm going to multiply that by x minus 3 over x minus 3. And again, I could just say, oh, cancel, that's 1. So that would just keep it 2x plus 4 over x plus 4. But I'm getting a common denominator here. So then I have x squared plus 6x plus 8, because I FOILed this, over x minus 3 times x plus 4. And then here, when I FOIL, I get 2x squared minus 2x minus 12 over x plus 4 times x minus 3. So yes, I could add or subtract now that they are common denominators, just as normal rational expressions go. Like to add 2/4 and 3/8, you need to make the 2/4 4/8. And then you can do 4/8 plus 3/8 is 7/8. Same thing here, you just have x's. Okay, addition and subtraction. Adding and subtracting. So, this equation is 5x over x plus 3 plus 3 plus x over x squared minus 9. So first, we have to look for this least common denominator. I see this x plus 3. I see this x squared minus 9. I want to find out what this x squared minus 9 actually is. So I factor it to x plus 3 times x minus 3. And I see x plus 3 here, x plus 3 here. The thing that's missing here from this denominator is an x minus 3. So my least common denominator is just x plus 3 times x minus 3. So this 5x over x plus 3 needs an x minus 3 in the denominator. So it is multiplied by x minus 3 over x minus 3. And then I can simplify that to 5x squared minus 15x. Then I take it down. And then once these denominators are the same, you can bring them under the same roof, I guess. So you just need this one denominator here instead of both of these. So then it'll be 5x squared minus 15x plus 3x plus 3 plus x. Don't know where I was getting a 5 from there. And then we just simplify this to 5x squared minus 14x plus 3 over x plus 3 times x minus 3. And many times you will be able to factor this out and then simplify the denominator with the numerator. But in this case, we just do not have the option to do that. Okay, last but not least, subtraction. So, with subtraction, Whoa. Sorry. We are doing x over x minus 1 minus 1. The least common denominator here is x minus 1 because here is a 1, which doesn't mean anything. We don't care about the ones in the denominator. But we have an x minus 1 here, and this equation is missing an x minus 1 in the denominator. So our least common denominator is x minus 1. So we have x over x minus 1 times x minus 1 in the numerator and denominator. We simplify that to x over x minus 1 minus x plus 1 over x minus 1. Then we bring them under the same roof, I guess. X minus x plus 1 over x minus 1. We simplify these x's, and then it goes to 1 over x minus 1. I hope that was helpful. Thank you for watching. Suggest any new videos you would like me to make. Thank you.